Angkor, 2 layers, precession numbers, 1,000 square kilometers under the jungle. The same code as Giza and Teotihuacan. But where did this code begin? The oldest candidate isn't in Egypt. It's in a place the textbooks barely mention: Iran. 2001. Southeastern Iran. The Halil Rud River floods. Not a seasonal rise, but a wall of brown water ripping through the Jiroft Valley, stripping away topsoil that had been accumulating for millennia. When the water recedes, the local farmers see something in the mud. Walls, foundation lines, the stepped base of what looks like a temple platform. Within weeks, thousands of artifacts begin surfacing. Chlorite vessels carved with mythological scenes, copper tools, ceramic figurines, cylinder seals. Looters arrive before archaeologists. By the time Youssef Majidzadeh of the University of Tehran reaches the site and begins systematic excavation, entire layers have already been gutted. But what survives is enough to rewrite the map. Majidzadeh's team uncovers a stepped temple platform, a ziggurat, that radiocarbon dating places in the late 4th millennium BC. That makes it contemporary with, or older than, the earliest known ziggurats in Mesopotamia. The carved chlorite vessels, intricate, technically demanding, depicting scorpions, eagles, and human-animal hybrids, appear across a trade network stretching from the Indus Valley to Mesopotamia. And the inscriptions on some of the artifacts use a symbol system that is not cuneiform. It predates cuneiform, a writing system that existed before the one we were taught was first. The neat summary says, civilization began in Mesopotamia. Sumer invented writing. Sumer built the first cities. Sumer gave the world law, mathematics, astronomy. But the Halil Rud stripped that summary bare, because what was sitting under the Iranian topsoil doesn't fit inside it. The river didn't read the textbook. And here's the question that Jiroft opens and won't close. If a civilization this advanced existed in southeastern Iran before Sumer, where did it come from? To answer that, you have to go somewhere no archaeologist can dig. You have to go underwater. The Persian Gulf. Today, shallow, warm, oil-rich, average depth about 50 meters. Maximum depth at the Strait of Hormuz, roughly 90 meters. But during the last glacial maximum, around 20,000 years ago, sea levels were 120 meters lower than they are today. The Gulf didn't exist. Where you now see shipping lanes and oil tankers, there was a river valley, an extension of the Tigris-Euphrates system, fed by freshwater springs, flanked by grasslands and wetlands. Jeffrey Rose of the University of Birmingham published a landmark paper in Current Anthropology in 2010, calling it the Gulf Oasis, a fertile lowland sheltered from the arid climate of the surrounding region, potentially one of the most hospitable environments on Earth during the late Pleistocene. And now, the numbers. The Gulf flooded gradually between roughly 18,000 and 8,000 years ago as the ice caps melted. 120 meters of water rose over 10,000 years. Any settlement on that valley floor, any village, any city, any temple, is now under the seabed. An area of roughly 230,000 square kilometers, the size of Great Britain, submerged. Rose's paper documents over 60 known archaeological sites ringing the current Gulf coastline, all dating to periods when the water was lower and the valley was habitable. The density of those sites increases as you move toward the center of the former valley. The deeper the water, the more sites the pattern predicts. And not a single systematic underwater archaeological survey has ever been conducted across the Gulf floor. We've mapped the surface of Mars with higher resolution than the bottom of the Persian Gulf. An entire country's worth of land, drowned, unexamined, ignored. Not exactly a gap in the data, more like a canyon. That's where the neat summary starts to crack, because the Sumerians themselves told us where their knowledge came from, and they pointed straight at the water. Sumerian texts describe beings called Apkallu, sages, half fish and half man, who emerged from the sea and taught humanity the arts of civilization, writing, agriculture, architecture, law. The Babylonian priest Berosus, writing around 280 BC, recorded the tradition. Before the Apkallu came, humans lived without order, like animals. After their arrival, cities, temples, irrigation, mathematics. The texts are specific. The Apkallu came from the waters of the Persian Gulf. Mythology, says the neat summary, creation myth, allegory. Wait, a civilization older than Sumer sits under the topsoil of Iran? A fertile valley the size of Britain sits under the Persian Gulf. And the Sumerians' own texts say, our knowledge came from beings who emerged from that water. The myth points at the exact location where the geology says a habitable world once existed, and then drowned. Maybe it's allegory. Or maybe the Sumerians were doing something simpler, remembering. Not inventing gods, describing refugees. People from a flooded world who walked uphill, carrying what they knew, and arrived in Mesopotamia with a ready-made package. Writing, agriculture, law. No intermediate steps needed, because the intermediate steps happened somewhere that's now 50 meters underwater. Refugees carrying civilization in their heads, and we filed it under mythology. Efficient. But if Iran's surface holds a civilization older than Sumer, and its seabed hides something even older, then the engineering on the plateau should show the same impossible depth. And it does. Iranian Qanats, underground aqueducts, hand-dug tunnels, typically 1 to 2 meters in diameter, running at a precise gradient from a mountain aquifer to a surface outlet, sometimes dozens of kilometers away. The principle is deceptively simple. Tap into the water table at elevation, let gravity carry the water through an underground channel to the lowland settlement. No pumps, no external power, just a perfectly calibrated slope. The scale is where it stops being simple. Iran has an estimated 300,000 kilometers of Qanat tunnels. 300,000 kilometers. That's 7.5 times around the Earth. Hans Wolff, writing in Scientific American in 1968, called it the greatest engineering achievement of the pre-industrial world. The total volume of earth removed from these tunnels exceeds the volume of the Great Pyramid multiple times over. Each Qanat requires a chain of vertical shafts, some over 70 meters deep, dug at regular intervals along the tunnel route for ventilation and spoil removal. A single Qanat can have hundreds of shafts. Multiply that by the tens of thousands of Qanats still functioning across Iran, Afghanistan, and Oman. And the gradient, here's where it gets uncomfortable for the tidy version. The tunnels maintain a slope of roughly 1 to 2 meters per kilometer, over distances of 30, 40, even 70 kilometers. In total darkness, without laser levels, without GPS, without line of sight. A deviation of a few degrees over that distance, and the water pools in one spot and never reaches the outlet. Too steep, and the flow erodes the tunnel walls and collapses the structure. The builders got it right, over and over, across 100,000 individual projects for thousands of years. Some of these Qanats are still delivering water today. The same tunnels, the same gradient, the same flow rate, after 3,000 years of continuous operation. Modern concrete infrastructure has a design lifespan of about 80 years, 7.5 times around the Earth, underground, by hand, with oil lamps. And the gradient is still accurate. 3,000 years later, the water still flows. So the tunnels are impossible by modern standards, but the people who built them weren't just engineers. They were also surgeons. Shari Sokhta, the Burnt City, Sistan-Baluchistan province near the Afghan border, a 5,000-year-old urban center occupied from roughly 3,200 to 1,800 BC, covering over 150 hectares.
Excavations led by Sayed Mansour Sajjadi of the University of Tehran uncovered something in a burial site that stopped the team cold. In the left eye socket of a female skeleton dated to approximately 2800 BC, a hemispherical object. Lightweight, precisely shaped, made from a natural tar derivative mixed with animal fat, with a surface so smooth it reflected light. Microscopic analysis revealed fine gold wire, less than 0.5 millimeter in diameter, embedded in the surface in a pattern radiating from a central point. The object was an artificial eye, a prosthetic custom-fitted to the socket with a decorative iris pattern made from gold wire thinner than a human hair. The socket showed no signs of rejection or infection. The eye had been worn in life, not placed after death. 2800 BC, an artificial eye with gold wire finer than a modern jeweler's standard gauge. The first known prosthetic in human history. And it wasn't crude. It was custom-fitted, cosmetically finished, and biologically tolerated for years of daily wear. But the medical sophistication at Shari Sokhta doesn't stop at the eye. Skulls recovered from the site show evidence of trepanation, surgical removal of bone from the cranium. Clean-edged holes with signs of healing around the margins, fresh bone growth ringing the openings, meaning the patients survived the procedure. Not just survived, healed. The cuts are precise, not ragged or accidental, but deliberate, measured, with consistent depth and angle. Brain surgery, 5,000 years ago. And the patients walked away. The site also yielded the world's oldest known backgammon set and evidence of a textile workshop producing dyed fabrics. A city that mastered medicine, metallurgy, and manufacturing simultaneously. A prosthetic eye with sub-millimeter gold wire and successful neurosurgery in a city the syllabus barely mentions. Not bad for people who were supposedly still figuring out agriculture. But Shari Sokhta gives us medicine. The next layer gives us something harder, chemistry. And this is the part where the depth of Iranian technology starts to look deliberate, not accidental. Arsenical bronze. Before the tin bronze that defines the conventional Bronze Age, metal workers in southeastern Iran were alloying copper with arsenic. Christopher Thornton of the University of Pennsylvania documented this in the Journal of World Prehistory, a tradition stretching back to at least the 5th millennium BC. Arsenical bronze is harder than pure copper, holds a sharper edge, and casts more precisely. It was the dominant alloy across the Iranian plateau for over 1,000 years before tin bronze replaced it. And here's the detail that no one wants to sit with. Arsenic is volatile. Its boiling point is 614 degrees Celsius. Copper melts at 1,085 degrees. To alloy the two, the smelter must heat the ore above copper's melting point, while keeping the arsenic from boiling off completely. That means controlling furnace temperature within a window of roughly 30 degrees, at 700 degrees Celsius, using charcoal fires and clay-walled kilns, with no thermocouple, no pyrometer, no digital readout. Too hot by 40 degrees, and the arsenic vaporizes, gone, and so is the alloy. Too cool, and the copper won't flow, and the arsenic fumes are lethal. The Smiths knew that. Some skeletal remains from early metalworking sites show bone lesions consistent with chronic arsenic poisoning. They were killing themselves to make this alloy. They did it anyway, for 1,000 years. Temperature control within 30 degrees at 700 Celsius, with a clay pot and a pile of charcoal. The tidy version calls this early experimentation. Engineers call it process control. Now, the strangest layer. Because what's on the islands of the Strait of Hormuz doesn't fit any geological model. Qeshm Island, the largest island in the Persian Gulf, sitting in the mouth of the Strait of Hormuz, the most strategic maritime choke point on Earth. On the western coast of Qeshm sits a formation known as the Valley of Stars, Chakku, towering columns of rock carved into surreal shapes by what the geological explanation attributes to wind and water erosion over millions of years. Standard weathering, case closed. Except the columns have features that wind and water don't produce. Some surfaces show a glazed, vitrified texture, the kind of finish you get when stone is exposed to temperatures exceeding 1,200 degrees Celsius. Melted and resolidified. Run your fingers across these surfaces and the texture shifts, from rough, granular, weather-beaten rock to something smooth, almost glassy. The geometry of certain formations, parallel grooves, repeating angular cuts, concave surfaces with uniform curvature, doesn't match any known erosion pattern. Wind erosion produces rounded, irregular shapes. These are angular, repeating, almost modular. Some columns stand in rows, spaced at intervals that look regular enough to be measured, not random enough to be geological. No published geological survey has explained the vitrification. Sandstone doesn't vitrify from sunlight. Limestone doesn't glaze from rain. Lightning can vitrify sand into fulgurites, but fulgurites are thin, branching glass tubes, not broad, glazed surfaces across entire rock faces. Something subjected this rock to extreme, sustained heat, and nobody has identified what. Melted stone in the mouth of the most strategic strait on Earth. Erosion doesn't produce glaze. Lightning doesn't produce geometry. Volcanism hasn't been active here in the relevant time frame. The geological answer shrugs. And the strangeness continues, because directly beneath the strait, inside the rock itself, the tunnels begin. Namakdan Cave, southern Qeshm Island. The longest salt cave in the world. Over 17 kilometers of mapped passages cutting through a massive salt dome. The cave sits beneath a strategic choke point where roughly 20% of the world's daily oil supply passes through in tanker traffic. The salt dome itself is ancient, pushed up from Precambrian deposits by tectonic pressure, a geological formation hundreds of millions of years old. The passages are self-excavating. Salt dissolves in water, and seasonal rainfall slowly carves new channels while older ones collapse. That's the geological explanation, and it's mostly accurate. But there's a layer underneath. Preliminary surveys have noted sections of the cave system where tunnel geometry shifts from the irregular organic shapes of natural dissolution to straighter, more uniform passages with flattened floors and squared-off walls. These sections have not been formally studied. No archaeological team has investigated whether any portion of the Namakdan system was artificially modified. 17 kilometers of tunnels, under a strait that controls a fifth of global energy. Sections that look carved rather than dissolved, and not a single formal investigation. The cave has been mapped by speleologists for geology. Not a single archaeologist has walked those passages with a dating kit, a strategic gap that nobody seems interested in filling. The salt dome itself is a time capsule. Salt preserves organic material almost indefinitely. If anyone ever modified those tunnels, the evidence would still be there, sealed inside the walls. But no one has looked. Salt tunnels under the world's oil highway. Some sections look carved. No one has checked. That's either an oversight or a decision. And now, the thread that pulls everything together. Because one artifact type connects Iran to sites on opposite sides of the planet. Carved stone reliefs from Jiroft, among the chlorite vessels recovered from the Halil Rud sites, depict a motif that has no business appearing in southeastern Iran. A rectangular container with a curved handle on top, held in one hand by a humanoid figure. The handbag of the gods. The same motif, nearly identical in proportions, in grip, in context, appears at Göbekli Tepe in southeastern Turkey. Carved on Pillar 43, one of the oldest known monumental reliefs on Earth, dated to approximately 9,600 BC. 3 figures, each holding a handbag. The same motif appears in Olmec and Maya art in Mesoamerica, stone reliefs at La Venta, carved figures at Tula, depictions at Copan. The same shape. The same grip, the same proportional relationship between handle and body. 3 continents, 3 civilizations that the syllabus says had no contact. One artifact, repeated with a precision that can't be accidental. A rectangular container, not a decorative flourish, not an abstract symbol, but a specific, functional-looking object that the same type of figure carries in the same way across cultures separated by oceans and, officially, by thousands of years. You'll say, coincidence. Fine. Then explain how 3 civilizations independently invented the same object, gave it to the same type of figure, and depicted it with the same proportions, without ever meeting. Cross-referencing these artifacts doesn't produce coincidence. It produces a network. A signal that something, knowledge, people, or both, moved between these sites. And Iran sits in the center of the map. Here is what we have. A civilization in southeastern Iran, older than Sumer, with ziggurats, a writing system, and a trade network spanning the ancient world. A fertile valley the size of Britain, drowned under the Persian Gulf, never surveyed. Sumerian texts that say their knowledge came from beings who emerged from those exact waters. 300,000 kilometers of underground aqueducts with precision gradient, 7.5 times around the Earth. A city with prosthetic eyes, sub-millimeter gold wire, and successful brain surgery, 5,000 years ago. Metallurgy requiring temperature control within 30 degrees, using clay kilns and charcoal. Vitrified rock on an island in the most strategic strait on Earth. 17 kilometers of salt tunnels beneath it, partially unexplored, partially unexplained. And artifacts identical to finds at Göbekli Tepe and in Mesoamerica. The neat summary says, civilization began in Sumer. Sumer invented it all. Iran is a footnote.
The evidence says something different. Sumer didn't invent civilization, Sumer inherited it. The writing, the cities, the ziggurats, the mathematics, none of it appeared from nothing. It appeared from somewhere. And every line of evidence, the ruins, the geology, the texts, the engineering, the artifacts, points at the same place: east, toward the Iranian plateau, toward the drowned valley of the Gulf, toward a world that was old before Sumer was born. The question isn't whether Iran predates Sumer. The ruins already answer that. The question is how far back it goes, and whether the real cradle of everything we call civilization is sitting under 50 meters of warm, shallow water that no one has ever properly searched. That's your call. The data is on the table. Iran isn't a footnote. Iran is the first page. And we're still reading the cover. Under the sand, a city older than Sumer. Under the water, a flooded world. On the island, melted rock and salt tunnels. And Iran holds more, a 5,000-year-old language that no one can read, a fortress that stood for 2,500 years, built from mud. Next, the part of Iran that the textbooks erased completely,